And we should be live. Daniel, hold on just. Daniel, hold on. Apparently there is no sound. No, hold on. Yes, that was the thing that I didn't get to do, and I apologize for not catching that. You should have audio now.
Okay. Okay. So we're going to redo that. Welcome, everybody. This is an episode of Meet the Maker. It's something that we put on. We try to do it once a month. It's been a little while, but we use this to meet makers in the community that have cool projects. And, maybe that we haven't been able to talk to before. We know the community may have questions. There may be things that people have been thinking about doing on their next build and want to get some information from the source. This installment we have Zruncho, who has a laundry list of projects that he's been involved with, and I'm guessing even some that we're not aware of, but I'm sure are either part of our printers or things that we're thinking about doing to our printers. Um, Dude, I went to your GitHub yesterday just to refresh, and there are so many things. You are buried in the community, at least in the DIY world that we live in. So it's an honor to have you on the show. Um, for people that first time watching Zruncho, just so you know, this is really we just try to have a discussion. We're just talking about again, the stuff that we all love doing. We do take questions from the community, so if anybody has questions, please throw it in chat. We'll do our best to go through that. We do have a part of it that will break up sometime usually around the middle or towards the end. We'll ask a couple trivia questions, so hopefully you have one or two things you can think of that we could ask you because we try to do some giveaways and stuff like that. But yeah, let's get started. Do you want to introduce yourself?
Sure. Yeah, my online handle is Zruncho. I'm happy to be here, everyone, and to answer your questions. And the short version is I've been a maker since years that started with a one. And since COVID, I've been really involved in the Voron and adjacent scene of building especially small printers, Printers France. If you go to 3dprintersfrance.com, a lot of that is printers that have interesting kinematics or really significant mods that I've done mostly to DualingZero. So really small printers. And
Yeah.
if there's one thing to learn, it's that I happen to live in a relatively small space. So I don't have lots of room for giant printers, but you can fit a lot more small printers in the same space. And so I've done lots of variants. And it's been really fabulous to interact with the community. And that's really why I'm involved. It's not the printers in the end. It's the people are a lot of fun to learn from that and to not just push your own technical capabilities, but also to have that journey with others.
Yeah. A lot of the projects that you work on, are they, do you leverage the community members at all?
So I do things that are all the way on the spectrum from one guy in a cave, me occasionally. Double Dragon was an example of that, where actually there was a video online that a YouTuber had done that showed how you might do an IDEX, so a printer that has two heads on the same rail. They both share that same rail, but it gives you this really cool multi-material capability. And that was like 6 weeks, start to finish, very little involvement from others. And then the other side, you have like structured beta programs that I lead, where there's no way in hell that the whole thing would have happened without the support and the encouragement and the actual beta testing from others. And so the last one that I did there on the other end of the spectrum, right, the more community involved one, is a toolchanger conversion called MadMax. And this allows you to take a printer that you've got, really pretty much any kind of printer that has a front-facing rail and has Core XY gantry, and add a second head to it. And unlike some other methods, you're not adding weight like with an IDEX when that head moves around. So you can get really, really good performance, but then you also have that second material capability without mixing in the nozzle, which can create some issues. And the cool thing is you can do that to the printer you already have for less than $100. You can print the parts in one night. You can build most of what you need in one day, probably one night, and then one other night, one additional stream unit like a Steve Builds or a narrow stream unit. You can do all the configuration. So actually, Steve Builds the last few weeks has been converting his Tridex IDEX over to a MadMax, Trident MadMax, and that's been really fun to watch someone else go through the same steps, just starting from a link. That's the level I always try to get to, that if someone sends you a link, you can succeed with that project. And in practice, you're probably going to want to engage the community and figure out, what's the latest mod, what's the best thing to use, what's, stuff people have learned since that GitHub got published. But I try to make it to a level of documentation and polish to where if you go to that link, there's a really good chance that you're going to succeed.
That's awesome. Sorry, I muted myself because I've got a bunch of kids outside and my dog loves barking at children. That's awesome. I mean, I actually saw, it was a while back. I think you have a Tri-Zero that's got it built in there. I think it's on your GitHub too. And it looks like, I mean, you've got set up here. I mean, it's pretty incredible. So you're able to fit two tool heads on what I assume is a 120 millimeter build size.
Yeah, actually, I destroyed that 2 weeks ago.
Oh gosh, okay.
By popular vote. So we're on Discord.
On a V0. So I mean,
yeah,
really, there's no limitation though, as far as, I mean, you can do these on small printers. If you look at the GitHub, there's one on a Trident, which I assume, I mean, you could put multiple on there if you want. It shows two, but it looks like there's room and you could potentially add others. Is that right?
Yeah, actually, that green Tri-Zero is no more. And that's by community vote. So on the Voron Discord and the build showcase, I asked people which of the 5 printers do they care about least, so I could figure out which 4 to keep. And I realized that my Double Dragon I hadn't touched in a long time. This is a little blue IDEX, V0 mod, of course, and then another one being this green Tri-Zero. So it starts like a V0. This is cute tiny printer, really fast, but the bed goes down and it's supported on 3 points. That was a mod I did a few years ago that adds automatic bed leveling. I realized if I combine those two into one, that would be pretty interesting. And actually, I was working on it yesterday. Do you want to see it?
Yeah, totally.
Yeah, I'll lay it flat and then I'll flip my camera right down. I think this will be a good explanation. Yeah, let me turn off the blur and you'll take a look real quick. Yeah, so this is an upside down. This used to be an IDEX. And now it's a MadMax. So it's a tool changer and it's magnetic. So you can just grab each of these heads. You can hold them in place. The docks are all real simple and magnetic. And the way it works here, this is also a Tri-Zero bed. So it goes up and down, does the wobble thing to do the alignment. You need some kind of sensor, right? So there's a kind of hidden feature about this design. Now, normally, like if you look at a Prusa XL, the head gets locked into place. There's a bar that slides in and there's a bearing that rolls and a spring and it kind of locks it in. It's called a positive lock. That's generally a good thing because then your head can't pop out as it's printing. But if you have enough of a magnetic attachment and you need to detect if the head's in place anyway or else the printer should shut down, there's something called Maxwell probing. So has anyone here heard of a Maxwell coupling? It's called a kinematic coupling, so it's really repeatable. If you have, these are pins, pins, and pins, and if you have 6 pins in a triangle, here, a little easier to see this way. Yeah, so if you have your pins, and then you have 3 spheres. It has this really cool property where it always aligns in the exact same place. And so that nozzle tip and that nozzle position is always going to be the exact same every
Yeah.
time you reconnect to it. And this is how a lot of tool changers work. What's different about this one is that it has some extra features, like you can use it to probe the bed. I don't know if you can hear that, but it sounds like a little click.
Mhm.
And that's abusing the Maxwell coupling there, to where when you push the head, it slides out. And there's a little a wire behind it right here where my finger is, that connects the left to the right. And when those 2 metal pins are connected through these pins here, your head can detect that. So I think that's kind of a cool feature. And there are a few other things too. It's super simple with some magnets. It's also got these pinned belt clips, so you can pop out you can do maintenance on your motors or
Yeah.
whatever you need. You can switch out this carriage if there's an issue with it, and then when you want to put it back in, that's it. So I
Oh,
think
that's
this is
awesome.
in a single view, captures a lot of what I try to do with mods, and why someone should maybe take a look at the website if they get a chance, my GitHub. It's that a lot of these things are quality of life. So you never have to worry about, when you change out
Yeah.
your bed, remembering that, or every time you do maintenance, it's extra work if you have a V0
Did
to
I
level
see,
that bed. And
did I see that
brings
right?
some quality of life.
If you remove that pin on the top, what's actually holding the belts together is oh man. So you can take out your carriage, do whatever you need to, and not actually have to rebelt anything.
Exactly. And I think there's a
Dude,
really good lesson
that's
for the
amazing.
audience here. Like, I do the things that make my iteration speed faster. And when you think, okay, I'm designing a tool changer and I have this idea for a magnetic coupling, but I'm going to get it wrong. I'm going to get it wrong for a long time. I'm going to have to do lots of iterations over and over and over. So from the first version, 2 features are worth pointing out here. So one of them is that in the back, you can't exactly see it on this one, but you can see it here. Got a lot of holes there. Like, why are all these little holes here? It's because you can take an Allen wrench, stick it in, and you can pop your magnets out very quickly. And so a feature like that enables you to very quickly destroy what you just built and then make the better version. Another thing is, if you can pop out your belt clips and iterate on this part here, which I did 20 times without having to redo my tensioning, then it just speeds things up for you. And then as a side benefit, of course, you get really nice quality of life when you're setting it up. So these are what I call speed clips, and they have this advantage. It's almost like a screw terminal, if you've ever seen one for wires.
Mhm.
So there's a screw right here, and that screw tightens a little aperture where the belts are. And I had the problem where some belts are thicker than others, so you can't set one size to be just perfect. You need to adjust it based on your belts. And so if you have this aperture open like a screw terminal, and then you get your belts to the exact right position, and then you cinch it down, you're good. So little features like that really spark joy for me, because they speed up my iteration cycle. And I'd encourage others, when they're designing mods, think you're not going to get it right the first time. But if you get it right the 20th time, what are the things you should do on the first time that might get you to that 20th time a little faster? So I'm pretty excited about that, because that project MadMax took about 2 years to get right. And that was a process that involved a lot of other people. And when we released it, over 10 people had their printers doing 2 extruder prints, which I thought was pretty cool.
Oh yeah, that's amazing.
So I'll switch back to the face, put this away. But hey, it's a V0, right? So you can set it next to you on your desk, and it's no big deal.
Yeah, well, and that's awesome too. I mean, we have a Tri-Zero in the shop, and it is incredible. In fact, every time I have a V0 that's been in pieces here for a year. It's been a long time. And yeah, I mean, it's my thought to be able to convert, only because yeah, the being able to retrim the bed is amazing. The V0 is a fantastic printer. It's like it was my go-to printer. But that is the one area where I'm like, yeah, this could be a little bit nicer. And the Tri-Zero just solves that. It is so wonderful. We've got a beacon on it. It takes like 5 seconds. It does its thing. It's amazing. And there's my
Uh,
dog again.
I'm excited about this one, because the heads are on the side and it's a widened V0. It means pretty much the full bed plate is
Mhm.
available for 2-color printing. And if you take an existing printer and you lose the front corners on a V0, you're losing half of your space or more. Whereas if it's a big Trident, you barely notice.
Yeah. No, that's amazing. So yeah, I mean, there's been a lot of people asking about MadMax. I mean, that's definitely one of the things that at least I hear more and more people talking about. Um, you've got other projects, other things that you've worked on. Is there anything that you're particularly proud of, or you had a really great experience that sort of stands out for you?
Uh, I think sometimes the end result doesn't reveal the complexity and the work that went into that end result. So I'll give one example. So when you're building a V0, it has these 15-15 extrusions that fit nuts. And the problem is those nuts like to fall down. And you can use gravity to your advantage. It's a small printer. You can rotate the printer around. But if the nut's just held in place, it'd be great. Now, we're used to with bigger printers, I don't know if I have an example handy, but yeah, the T-nuts that we're used to have a little spring and a detent, and so they hold in place. And so we don't have that on a 15-15. So one of the first mods I did back 2020-ish was called No Drop Nuts. And it was just a single little piece of plastic that would fit your nut.
Yes.
And it has all of these other benefits I didn't realize until I had started using them. One is if the nut is 15 millimeters long and the extrusion is 15 millimeters, you have this amazing way to never have to align anything again. So if all your parts have nuts in the middle of 15 millimeters, so let's say a 7.5 gap from the edge, then when you slide those no drop nuts into the slots, you just push them to the end and then everything is aligned for the parts that attach to it. And so with all my projects since then, everything is aligned to that 15 millimeter spacing and it just eliminates a lot of work. So I think that's one little example of a project that I thought was, it's a tiny little piece of plastic,
Yeah.
right? It's a 40-second print on a fast printer, but I think it really changed the output for a lot of builds that would have otherwise been just really frustrating.
Oh yeah. No, I remember filling up like a 350 plate with, I mean, it was well over 100 for sure, like 300 of these things. I mean, it's amazing.
And then
And
one
yeah,
other
super quick print,
example, if you want. Yeah.
super quick print. Um, are there any, are there any, I mean, we can go back to Mad Max because I mean, definitely that's, uh, again, that I think is a really popular project right now. You mentioned you showed the pins, sort of and how the sort of the carriage mounts to the tool head. Are there any challenges with that method as far as repeatability for taking off I guess, redocking and taking off a new tool head? Is there, um, I'm guessing, I would think it's fairly reliable, as long as there's not like a collision or something that happens sort of in between. But are there any challenges that you faced to make it that way?
So it's a good question. So maybe we'll zoom out for a second. So anytime
Okay.
you have a multi-material, multi-head system, whether it's an IDEX or whether it's two completely separate gantries, we have that too, but I won't talk about it too much because it gets a little complicated to line with that. Or you have a tool changer set up with any number of heads. Those nozzles are going to be a little bit off, right? You're
Yeah.
not going to build two of the heads the exact same, even if they're CNC machined. If there's any slop anywhere, there's potential variation, right? Even just that fraction of a millimeter that a screw may not be exactly match
Yeah.
fit to its.
Which is why you have like calibration tools and things that will try to correct for those things.
Exactly. And so this is actually a spinoff from MadMax that people may not realize that a lot of people with IDEXs are using today or other tool changers. There's a probe called Nudge. And I don't know if I have an example handy here.
There's a great video. I think you have a video somewhere. Again, when I was digging
I
around
actually have
on
one handy.
GitHub.
Yeah, it's black, so it blends in. So
Yeah.
it's not very big. This is another project that is
Yeah.
deceptively simple, but was about 50 iterations to get right to where it attaches to anything and it's highly reliable. And for a few months of my life, I thought I was going crazy because every version had this same problem where it kept drifting over time until I realized it was the sensor, which was perfect. It was the belts, which were stretching, and I was measuring 0.02 millimeters of stretch. Belts are stretchy and they like to stretch and hold their position slightly. And so if you hit the probe a little bit 50 times in a row, you're going to see the position just drift slightly. And the direction of drift is going to vary based on how long the belts are and whether they're of even lengths. So based on where you do the probing, where you mount the probe, if you're trying to see how repeatable it is, you're going to see different results based on the direction, which will drive you insane until you realize that there's this thing called viscoelastic relaxation with belts. But anyway, this is an example of the kind of tool you need, either this or something camera-based or possibly like a bump with a piezoelectric sensor that gets knocked by the nozzle. And the way this works is each nozzle comes over to, let me get that in view, my head behind it so you can see it. So the nozzle comes along and it taps it and it taps it, and it does that in a few different directions, actually after it indexes to the Z. And if each nozzle does that and remembers its position where it found the center, then you can establish offset. So this is called offset calibration. If you have multiple nozzles and you need to figure out exactly what that little offset error is, because you're going to provide a number for that offset between them. But even, the same exact part, same printer, there's going to be some variation in that build. So that's critical to align the head so that you don't have, a little bit of a castle view when you look at the side of a box. So that's one thing. But your question was about the dock. And so the dock is actually designed for a level of misalignment. So this is the dock, and it's really simple. It's 4 keyholes, kind of like if you've ever had a surge strip attached to the wall or a wall plate. It's the circle and then a little circle next to it, and it's like the little circle got pulled into the bigger one. So if you stick your screw head into the big hole and then you slide it along, it's going to hold in place. That's exactly how this thing works. Really simple. There are magnets on the back that you press in, and then there are holes into which your flathead cap screws go, and then because they're steel, they get pulled in and held with the magnets. And so there's an amount of misalignment that these are designed to tolerate. It's about plus or minus 1 millimeter that you have to get your heights right. But then the forward-backward motion and the left-to-right motion are all about 1 millimeter of misalignment is fine. And it was intentionally designed that way so that you didn't have to have perfect alignment. Or if you had something else in your system that varied each time, for example, if your end stop varies a little bit, then your dock alignment's going to vary. And so you have to design for tolerances, for the tolerance in the end stop homing sequence, for the parts are going to move slightly as your printer heats, right? As the frame expands, the distance between one side where you did your homing and the other side of the printer where you're doing your docking is going to vary. So you want to make sure that you're tolerant to those misalignments in general.
Oh, interesting. Yeah. So, and I mean, 1 millimeter seems pretty forgiving. I imagine, in stops and stuff like that. I mean, that would be like if you were going plus or minus a millimeter, or even half a millimeter, like that would be pretty intense. So you built in a lot of room for error.
Yeah, and the good news is you can get about 0.01 millimeter repeatability off of this very, very simple device. It's also a Maxwell coupling, very simple. It's 3 screws. You see these little copper. It's just button head cap screws, and then they fit into the same kind of thing.
So
harder to see.
At 0.0, I mean, at 0.01, I assume that's sort of within what would be considered sort of a normal error that any 3D printer sort of on any wall would end up having. So you don't even, I'm assuming it doesn't show up very much even as like banding or anything like that you would, or anything additional than what you're already used to seeing.
No, and honestly, the concentricity of the nozzle, the center versus the outside could be slightly off, and we're measuring the outside. So we're at the scale where we're not going to care, right? This is all hot glue gun pushing hot glue through. So it's not that accurate, but we can still see the error between probing cold and probing hot. So just that difference, right? Your nozzle expands downward. It may twist one head relative to another if it's built just slightly differently. Your frame is expanding, and that's creating some differences for where to dock things. But interestingly, when you do your nudge probe hot versus cold, I've seen differences of 0.1 millimeters. And this is a level that you can actually see on prints.
Oh, yeah.
See a little castle on the edge. So just make sure you probe in an environment that matches your print at the full temperature after things have all settled.
Yeah. And that's good general advice, everybody. Because I think we are, a lot of people in our community obviously are printing with ABS or similar filaments. We're enclosed. We try to
and get really good results.
That's almost trippy looking.
Yeah, if you do alternating a few layers, and Prusa Slicer has that kind of built in, you can get some cool effects. If you do a shiny and a dark, it doesn't quite look like either of those.
Yeah, that looks awesome.
So this is my example of a print that's a little bit off in its calibration because I didn't probe hot. I probed cold and then it got to temp, and so there's a little bit of a I don't know if you
Yeah,
can
but
hear that. I'm running my finger. You shouldn't be able to hear
yeah,
anything, but
yeah.
because there's that castle stair step kind of thing, you can just barely make it out. Yeah. Anyway,
Well, that's awesome. Um, so I'm kind of curious now. So obviously you built, I mean, you built MadMax. Do you have any other experience with multi-material or tool changer units, anything like that?
so I looked at the tool changers that were out there, but I hadn't built them beyond trying out the mechanisms that allow them to attach and detach. Of course, there's what is it? The E3D did a tool changer that used machine metal parts, and that's
Yeah.
just slower to iterate on and maybe not as accessible and price accessible. There was one called Tap Changer that Vsters did, and
Hmm.
major credit where credit's due. That software for Clipper that enables you to easily run a tool changer where when you do T0 or T1, it's going to find the tool changer, it's going to detect which one is there, it's going to not start your print until it detects that the tool changer is actually connected to a tool. You know, those basic functions don't exist in Clipper yet. And so to have a Clipper module that you can just turn on and then you can customize it to a slightly different method. So Tap Changer uses Z motion, so your whole gantry has to move to then connect to the tool. And so if you have something like a V2, that makes a lot of sense, a flying gantry machine or an F-Zero or Micron. But I kind of like fixed gantry machines. I think they're easier to make really rigid. And for many people, they can be easier to construct as well. There's just less that can go wrong. And as I get older, I like to eliminate sources of failure, right? Tri-Zero is direct drive because it's good enough and it eliminates all those extra set screws that, in my experience, have come loose over time. So anyway, Tap Changer required some Z motion, but I didn't have too many printers that have Z motion, so I wanted one that only required X and Y motion. And there are other examples of that. So Prusa has the XL, a commercial tool changer. It's been around for a few years. It has this locking bar that slides into place. There's a similar, like let's say a cousin of that, that uses the same principle and mechanism called Daksh that Encorv did. Amazing stuff. Look at the videos online of, 5 colors doing these beautiful, full print volume beds, vases. Uses the same kind of mechanism, but open source. I really like that because it's really fast to do a tool change. And I've learned that one of the key things for a good tool changer, good multi-material system, regardless of the type, is that you don't want drool. Drool is the enemy. If you have any little bit of drool, you're going to see it on the print. And the more drool you have, the higher the chance that when you get to the purge or wipe tower, you got to do a little more there, or that it catches or it finds its way off. You need brushes and blockers ideally before the nozzle leaves, and then you want to minimize the distance it has to travel and you want to maximize that speed. And so if you do those things, then you can get really amazing print quality. In fact, Encorv showed in some of his YouTube videos that you could have prime tower free printing where if your nozzle is blocked and then it very quickly goes and only has to move an X and Y instead of doing this whole Z motion thing to
Yeah.
go over to your print, you can do nice prints without a purge block. And
Yeah.
waste just feels wrong. It's why I've never built an automatic filament changer. And if I built one, I think it would be more for the convenience of pressing a button to select exactly the filament color or type that I want.
Yeah.
So yeah, I've tried all the multi-material methods except for the one where you have a single head that has tool head that has 2 nozzles. I just think that doesn't make a lot of sense because then you've got a lot of extra weight if you want to go direct drive, and weight is the enemy, right? Colin Chapman said,
Totally.
add lightness, and that's how you make Lotus cars fast. It's the same way with printers. The more weight you can remove from that head, the better it's going to print, because if that weight is doubled and those belts are stretchy, that means that head's going to move almost twice as, or something like twice as much. I don't know the exact physics there, but it's going to move significantly more when it's heavier as it rounds a corner, which means you have to slow down the printer, or for the same speed, you have to accept a reduced print quality. And so lately, a lot of the stuff that I've been working on is very much in that direction of what are some of the first principles of really good motion systems. How do we get the stiffest belts, the shortest belts, the most rigid systems? How do we find ways to bump up that tension and shorten the length of those belts to get really good print quality, even without some of the things that can work around the limitations, like slowing down accelerations or deploying input shaper?
Yeah.
So there's an example project, if viewers are interested, in that direction, called Monolith by Cloak Dwayne, and it said, well, what if instead of having rails that are on top and then a bit of an offset, instead we face the rails inwards? And what if instead of shafts that kind of stick out and are cantilevered, cantilevers tend to be bad. They're just less rigid and they add the potential for motion, for little deviations that can be seen in prints. What if we double supported those shafts? And what if we changed the belt path? We flipped it inside out so that it was a little bit shorter. And some of the input shaper graphs that show how that system responds to accelerations are just literally off the charts. They're so far beyond what most people have seen that you have to change the default to raise it, because the frequency at which they resonate is so much higher. And that's a really, really good thing, because that translates to either higher speeds with the same quality or better quality for the same speeds. And I want to show something if you got a second here.
Yeah, of course.
I think this might be interesting. This is hot off the press, not quite done, not released. So I hesitate to show these kinds of things too much when you can't just go download them. But I think it shows the principle pretty well. So let me point the screen down real quick. There we go. All right, so this is a test gantry. This is for Monolith Zero. So Monolith is a much bigger thing, but Monolith Zero is something that Cloak Dwayne and I have been playing around with. He did the design, and I wanted to measure it and see how well it could perform, because I'm used to kind of like stock V0 gantries and then putting them in a box like F0 or moving them around. And this has a bunch of features that I think are pretty interesting. So you'll notice the belt path is really, really short. Belts just go around the corners. Another feature is that all of the shafts here are supported on both ends. And you potentially have a motor that has a long shaft that goes in there, or in my case, I didn't have those when I wanted to get started. So you can add shaft couplers to the end here with motors on top. And those shafts are right next to the corner of the frame. So where you've mounted the part that you don't want to have any motion on is it's the strongest part of that printer.
Yeah.
You'll also notice plates. These plates, or structural panels in general, are a really good technique to improve your input shaper response and get better prints. Because if there's, at the speeds that we're able to run with motion systems these days, if you don't have something structural on the outside, then you have the possibility that as that head moves in X like this, that there's actually motion with the extrusions. If you just have the extrusions alone, and some of the people who've deployed Monolith gantries with 2020, they've found that it's just not enough, that they need to increase their extrusions, or they need to start adding little structural panels here and there. And this is an area that I'm just really excited about, really high speed, really high quality printing, because it's just a new world for me, especially when you start to couple it with really high flow hot ends that dramatically reduce the amount of time that print is going to take.
No, that's amazing. And do you have, obviously this isn't released, so you don't have it on a printer yet. Do you have any idea of the kind of results that you would potentially be able to see on something like a V0?
So actually I do have it on a printer, and it's right there.
Yeah.
That's the little Monolith Zero.
Awesome. Do you have any idea? Have you run some tests?
Yeah, so I actually showed it off at Portland Vice a few weeks ago. This is kind of the first time anyone had seen little Monolith Zero in the flesh right there. And so this is weird in a lot of ways. So this is a V0, so it's really small, but it has 4 NEMA 17 motors, normal big motors. It has more travel than a default V0. And I was showing perfect Voron cubes printed at 400 millimeters per second, which is pretty high speeds. And if you don't have input shaper on, then you'll see a little bits of ringing, but because it's so rigid, it's just this super rigid box with very short, tight belts, it resonates at very high frequencies that are really easy for the input shaper edition clipper to kind of cancel out in that noise cancellation way. And so Cloak Dwayne has actually run his with sheet coolers on the side blowing inwards to improve the cooling capacity. It has a CPAP on top too, which is a weird thing for a V0, but goes well with the high speeds.
Yeah.
His is printed at 1 meter per second.
Wow.
And what I am used to is the one to the other side, which is, this is DualingZero. So this is a dual gantry printer. You have 2 completely separate gantries that can kind of fight and smash into each other if you're not careful with the software. It makes every print more exciting than it needs to be at the moment. It just has one head on there, but that's like my production printer. It's the one that I haven't touched in many years, and it continues to work very reliably, and it prints all the parts for the other one because I know it's going to work when I press the button. And just seeing the 2 together, the fast one makes the other one look like it's just moving in slow motion. It's just a different world in terms of speed, and the prints take about a third of the time, and I haven't even really pushed the speed. And in fact, the hot end for it is something else that the audience might be interested in. So SLM is, what is it, selective laser metal, I think, or laser machine. I don't know the exact word for it, but it's, you can send your part files to a service that within a week and a half will send them back to you for surprisingly low amounts of money. And then you'll get a thing made in metal that matches exactly what you've got. And so that printer there, the one I'm pointing to here, this is one of the hot ends. And this is, I think, really amazing for $15 or less, that you can share the part file and then a week and a half later get back from China largely a hot end that will do 70 cubic millimeters per second or potentially higher as the design gets optimized.
Wow.
I think that's it's a way to change what we can do design wise. And this is one of the top technologies in the last year or so that I think has become possible in ways that I didn't even realize, that you could get so much for so little. And so there are a few other parts on Monolith Zero right there, things like the Z joints, just a few bucks a piece. But if everything on the inside is metal, then it isn't just massively high speed, massively high flow, amazingly good quality, but it also can do all those things at a high temperature. And that's really interesting to me, that I can start to push to more engineering grade materials, especially those with fillings like glass fiber or carbon fiber, to get really strong parts. But in a chamber that doesn't have a problem getting above 60C, to where you can print really great ABS parts, or you can even push the needle a little bit and not have to worry about parts softening or deforming, or, the worst thing that can happen is you go a little too hard, a little too hot, and now you need to reprint your printer. And that's not going to be fun for anyone. But if everything is metal on the inside when you start, the frame is metal, the panels are metal, what do you have to worry about?
Yeah.
You can push that temp and not worry. The problem at the moment is I need to add some insulation, because while metal is very strong, it likes to conduct heat better than plastic. So I want to get that chamber temp up a little more quickly. And one of the paths is to simply add insulation.
Yeah, that's amazing. So that's definitely a printer that I want to build. That's awesome.
I just want the audience to know, this is like, there are two that have ever been built, and the moment you go from one to two,
tomorrow,
you'll learn a lot about what you don't like, and I think every single part in it is likely to change.
That's still awesome. It's something to look forward to.
So many interesting bits about it, and it was really great to see people's reactions at Portland Vice, and just because every decision about this thing is just different. In some ways, it's back to basics. Like, unlike Tri-Zero, it doesn't have 3 C motors. It just has one, kind of like an original V0, because it's trying to be simple and it's trying to put the money into things that improve performance. Yeah. And if you have 3 lead screws, but they're all coupled with the belt, then the whole thing's going to be pretty stable. And then you can put that money to other stuff like panels or more motor drivers, or the things that really push the performance. And then you've benefited because you don't have anything on the inside, a probe that can die with heat. So we try to remove everything that's going to die, like fans. And a lot of this is Cloak Wayne's design. And the notion that you would take CPAP ducts in metal, print them in metal, and then make them structural, blows your mind. Yeah. And you're able to get really great performance as a result, because that tool head isn't just rigid, but also that tool head is supporting the hot end at the bottom. So instead of yet another cantilever that likes to kind of bend as it moves around in X and Y at very, very high speeds, it's supported. It's structural. It's really rigid, just like, on a tube or many of the other hot ends out there, that supports the hot end at the bottom so that it can't wobble around as it moves at very high speed. So it's fun when you get to the next bottleneck and you learn something in that process.
That's amazing. So it sounds like the Monolith Zero is, you are consciously making an effort to make it accessible, at least financially, for individuals. It's not one of those designs where you have no constraints and you're like, sky's the limit, which we have projects that are fantastic that are like that too. But it sounds like you're making at least a conscious effort to simplify things.
Very much. And in some ways it's simpler, right? It's back to basics if it's one Z motor, but quad XY, as Steve Builds like to call it, other people call it all-wheel drive, but I think quad XY makes more sense. Quad XY with short belts, with a short belt path anyway, with double supported shafts, so you can really jack up the tension. And another example that's different is the tensioner is on the carriage. There's only one other printer I've ever seen do that. The V-Chunk, which isn't, I don't know if that's actively supported. That's a rat rig thing. So it uses some of these decisions that you wouldn't assume, but that have these nice benefits of, then you just have 4 screws in the front to pop out your tool head. Another example is the electronics are on the top, the ones that you're going to access all the time.
Oh, nice.
pop out a panel. So everything is toolless that can be, or I'm going to push for it to be toolless if possible. Another example, I'll unblur for a second. Just a few examples. So that the panel in front is a frame with a plastic panel in the center, and you can just pull it right off. And it uses a flexure to hold in place, and you can tune the flexure so it holds in place exactly the amount you want. In fact, you can grab it, pull it off, flip it around, make it left or right-handed, completely toolless. You can get to the electronics on top. You pull the top little plate right there, pull it off, and then slide the top plate above that off. So there are a lot of design decisions that I think I've realized over the years are really worth getting right. And Cloaked Wayne, who is the designer of that, not me to be very clear, shares a lot of that same design philosophy of if there's a printer you want to love, then you got to make the quality of life features things that you consider before you do the release, because those little things like how do I enable you to pop out the front panel so you can pull out your SD card if there's an issue, or access a USB port so you can do your input shaping measurements. How do you make those things toolless in seconds rather than minutes?
Yeah. I mean, I'm looking at it, and obviously you can't make too many assumptions just looking, but is it something that you see people that having a V0, like it's a fairly simple upgrade path, or I mean, it looks like there's probably some shared components. I'm assuming that Z motor, that lead screw 200 millimeter, I'm guessing is what I can't tell the actual height you got there, but it's probably I'm guessing it's the V0 Z motor. I'm guessing then it's the same build plate, same same build volume, I guess, on the X and Y at least. I assume somebody could start and say they've got 30% of their printer already with the V0. Is that right?
I wish I could say it was 30%. But
No,
all of the design decisions actually mean
no.
it's much, much less.
As I'm sitting here looking, I just every once in a while I keep looking back here because I'm like, okay, that's what you're changing into. But
It's
yeah,
a great, V0 is a great printer. Right? Leave it alone. It's not going to break on you. It's always going to be there for the parts you want. I mean, the other printer next to it, right, is you could say the same thing. It starts with the V0 frame kit, and then
yeah,
literally every part beyond that
mine's
is
been
completely
sitting just
different.
there in pieces like that. It's sad.
So yeah, DualingZero is a V0 frame kit, plus everything else is custom. All the panels are not the same. All the electronics are not the same. Everything is different. It's the same way with Monolith Zero, right? So Monolith Zero needs more drivers, so you can't use the same control board. It needs more power. I mean, just 150 watts isn't going to power the motors plus the heater, let alone the bed if it's DC. Everything has to change to really go for it. You need more power in the power supply. You need more drivers. It has a CPAP on it, right? So it has this blower fan that pushes through a tube so that there's no fan to die in a hot chamber. All those are different choices. And so the only things that get reused that I can think of are one Z motor. Maybe if you have a different printer, you pull the drivers, but the little SKR Pico with integrated drivers is not
No.
what you would use for this. There's only so much space on top. So we're using an Octopus. You're probably going to change the power supply. And so it's really just the frame and that single Z motor and maybe a few screws here and there.
Yeah.
Your Raspberry Pi, that's about it. And
Well, I
that's such a
imagine your
small
Z
amount.
extrusions, I imagine it's popular, and I'm looking at yours. I assume the Z extrusions are also marginally taller or longer.
Yeah, it tries to use all off-the-shelf stuff. It's another way where Wayne and I think are on the same wavelength. I always try to do mods that either reuse existing things like V0 frame kits, and maybe it's like the Lego kit. You assemble the parts in a slightly different way, and you get a different model, and it's satisfying to have built your own instead of the one that's on the box. Maybe you need a few extra parts for it. But these are a lot of different parts for it, but they try to reuse at least something there, because I know it's a pain for a lot of people to cut extrusions. So it only uses standard size extrusions, 200, 300, and 360, which are all
So you
maker
can buy
beam
them
parts.
easily.
And you can take a 100 and a 200, join it together. I did that with the Box Zero mod to make it a lot easier to enclose without any holes your V0. And so you can make your 300s just fine. And because they're connected to metal panels, I think it would perform the same as a 300. I haven't tested that, but I think it'd be fine. And then you can choose your favorite color.
That's awesome. That's cool. Okay, I still that's one of the printers I really want. I'm gonna go way back because you had mentioned when you were talking about MadMax and sort of your desire to keep everything on X and Y, and just to, I guess, speed up the time so you don't have those forgot what you called it, but the ooze that you get from the nozzle. kind of got me thinking because yeah, I mean a lot of these sort of Z is the slowest of the of the axes to move for most printers, I think. Um, I'm sure that does add a considerable amount of time, but I'm curious what your experience, and I'm assuming it's build related, but in your experience with MadMax, how fast are the tool changes?
Yeah, so it really depends on how you're driving it,
Yeah.
right? So it's that dwell time that will matter. And if your other head is preheated and ready to go, then there you go. And if you are alternating layers like I was doing in that sample part I showed earlier,
Hmm.
then you can kind of just leave them on the whole time because the time between needing to get to that head is very, very low. The other thing you can do with a lot of slicers now is you can bring them down to a temp where they're not cooking the filament over time, like
Yeah.
170 C or something like that. But then you have to wait when that head goes, when your carriage goes to grab the other head. So on my green Tri-Zero V0 Box Zero has all the mods, ZeroPanels, Vampire Bat, like 5 of the mods connected into one. I measured, I think it was 1.5 second or so total tool change times, and I had a test Trident gantry of similar size where I got it down to 1.2. And I
Wow.
think if I had actually, pushed things a little more, got the motors that everyone's using these days for higher speed, things like 2504 NEMA 17s, or even some of the more exotic stuff would do better, then I think it wouldn't be too crazy to do sub-second tool changes.
Wow. That's insane.
And at a full size, like a Trident 350 or 300 is exactly where MadMax shines, because who cares if you lose a little corner in the front?
Yeah.
You've got plenty of space to work with, and you've added such capability to that to do supports with a material on top, or to do two colors, or to do two completely different materials, like one is flexible and the other one is rigid. And I think those are some of the three most common use cases that we've seen. And so if you can start with really fast motion, I want to recommend to the listeners, there's software called AutoSpeed, and it's on the GitHub of a GitHub user called Anano AI, or ANONOEI. It's called AutoSpeed or Clipper AutoSpeed. For some reason, I don't think Google finds it on the first hit, so I wanted to spell out the author of it. If you have end stops that are reliable, like end stop switches instead of sensorless, then what it does is it moves the carriage over, and then it tries to go really quick, and then it sees if there was any slip. And this is really genius, because then you can binary search the speed at which you start to slip. So it really quickly gives you a way to see how fast can your printer go, and then you can derate from that. And that's the speed that you can run things at. I mean, you don't
Oh,
actually need it, right? You can run one of those Ellis speed tests that does a
yeah.
square, and then it does a smaller square, and then it goes back to the bigger square. And so it's trying all the motion directions
Yeah.
to validate that whatever speed you've picked is correct. But as you push the currents, as you get shorter belts, you start to get this ability to just really push things, not just for print quality, but also for the speeds that you get without slip. And
That's
there are more
amazing.
exotic methods too that I'm starting to see. Like one of the MadMax users, Andrew MCGR. This is someone who has added Clipper support for a completely new kind of motor control. Have you ever heard of FOC, or field oriented control?
Hmm.
So the stepper drivers we use have been the same way for many years. So when I started 20 years ago, it was really simple. We put a giant resistor in line to limit the current, and then just turn on a phase and turn it off. And so you'd only get coarse grain steps. But you had these giant brake resistors outside that got hot that you had to cool. So that's called unipolar chopper current limiting, where the chopping is, or not chopper, but resistor limited. The one after that is chopper drivers, where you have a circuit that's sensing how much current is going into that motor, and it's
Hmm.
chopping it. So the moment it gets above the threshold, it chops. So if you look on an oscilloscope, you'll see a sawtooth pattern. And we've had those for a while. They've gotten a lot better, and those give you the ability in software now to choose exactly the current that you want for that motor. You can also get motors drivers that do microstepping. All those chopper drivers can interpolate, or they can kind of guess at positions by drawing a sine wave rather than just having on or off and doing very coarse grain motion. That makes it much smoother. It also gives you fewer vibrations that you can hear, and gives you better positioning accuracy in the smoothness sense. The next level beyond that, right? The problem with these stepper drivers is, even if your stepper isn't moving, it's consuming the same amount of power. It's just a heater. It's a resistor. It's not moving. It's not doing any work, but it's receiving current. And so field-oriented control is a completely different way that requires a completely different kind of trinamic driver, where you can almost think of it as it pushes the motor to exactly where it needs to go. And from a magnetic pull standpoint, it's like trying to pull it 90 degrees. And so imagine you're kind of pulling that motor with the magnets as much as you possibly can at any given time. So it has to sense where that thing is and drive it to a particular position. So there's a lot more complexity on the electronic side, but the good news is there are chips. There's one called a TMC 4671 that does the work for you. So if you create a clipper driver for that and you write to it a position you want it to go to, then if you tune the control loops, typically a PID loop is what we use for our heaters, but you can also imagine that for the motion control side, then you solve many problems at once. For one, you don't waste all this heat when there's no motion. Two, there's no possibility of losing steps unless you get really, really way behind. Because if you have that little, if the stepper couldn't sense that it had slipped a step, but you've got an encoder coupled to that same shaft and a driver that's really pushing it hard to get there, you're not going to have to worry about any slip steps as you get towards the top speed of your motion, which is a reason to pull back typically with steppers. Another thing is you can get even faster motion because you can push that motor harder when you want to get it moving and then pull back when you don't. And so it's like this magical way to drive down the power consumption. And I've seen really clean input shaper graphs with printers that only have two motors driving it. In fact, when you run field-oriented control, you can grab the shaft and you can kind of twist it, and it's almost like it's resisting you actively. It feels incredibly stiff, stiffer than the belts would, because the motor is actively driving in the reverse direction to try to put it into that position that it's supposed to be at. And so you can get amazingly good quality once you get some of the tuning there. And Andrew MCGR, that's the name. He made this clipper module, and he was using it for months as part of the MadMax beta program. So he had this giant Trident 350 with these completely new drivers moving at amazingly fast speeds. I think his tool change times were sub 4 second. Wow. And the subset that matters is where you're going from the little blocker on the nozzle over to the print, or really over to the prime tower, where you just extrude a little bit and then you move over to your print. But that's very different than a purge tower where you have to extrude a lot of material so that it's all mixed. Like the mixing problem isn't a problem, right? It's almost like toothpaste in the middle. So you got to purge a lot with filament changers, and with tool changers, you don't need any of that. There's just a little bit of priming to get them started, and then they go ahead and do their layer on the print.
Wow, that's awesome. Yeah, no, that's amazing. And that's insanely fast. I can't imagine. I mean, those are really quick changes. And it's really awesome to hear about some of these things that hopefully more people start getting into. I mean, especially if it gives you more reliable print quality, stuff like that. I want to go back. Somebody actually asked a question just about reliability, or when you would need
Pretty
to
cool.
reprint docs due to wear and tear on the MadMax. And he said, I mean, he knows it's everyone's machine's different, but do you see wear on the docs over time?
Yeah, so Andrew was the first person to have that challenge, because he was doing long prints on his MadMax. It's a big Trident, so you can do these big prints, really cool stuff. And after enough cycles, the plastic wears. The good news is plastic is really cheap and the magnets are accessible. You can just pop them out. And so in a few minutes, you can solve that problem. And I like this notion of we can release things knowing roughly where they're going to fail. As long as that failure point is easy to fix, it's okay. And what Andrew is using was OpenFF board for his field-oriented control. Since then, there are now commercially available options that make it a lot more accessible. That's what I was fumbling around, if you heard that sound earlier. So this is an Ouroboros, beautiful anodized red heatsink. This thing can do much, much larger motors than I've got. So I think it costs a little more than you might expect. But as time goes on, things like this will become more accessible. And it's really interesting, right? Because you get to tune the loops. The only requirement is that you have, right now, a motor that has an encoder on the other end.
Yeah, those things are amazing. And Isix Tech does that, and his display, he put together a gantry at Rocky Mountain, and it was something else to walk by that thing.
250K excels, if I recall.
Yeah,
the entire weekend without issue, which is
definitely
another
if you put your
mind
hand
blower.
in there, you'd be in trouble. Like that thing was flying. Uh, yeah, it's wonderful. And yeah, I mean, it is spendy. I mean, I want to say it's over $300 or in that price range for that. But yeah, the results you can pull from it with the right motors is incredible. Um, let's see. Sorry, I was checking to see if we have any more. I'm going back and forth between. Oh, cool. It's apparently called someone on my watch. Um, okay, we've got some other questions that are put out here. Kind of changing tracks a little bit. Um, but 3D printing has really changed in the last 5 years, I'll say. With I honestly just better printers. 5 years ago, if you were looking for a high performance printer, Voron would have been, and you're willing to build it, that would have been probably the choice. And there's a couple other options. But commercially for, a normie person, there really wasn't much out there. That's not the case today. There's tons of printers that are all going to give you a fairly reasonable experience. Um, Obviously, the projects that you work with are for people that enjoyed the DIY experience. Um, what would you say would be sort of the reasons that, people are still going this DIY route?
I mean, I think this is almost like the existential question for the community, right? Does anything we're doing even matter in a world where, what was it yesterday or a day or two ago? Bruce drops a Core 1L and
Hmm.
it's probably going to give you a better out of the box experience than any Trident. It's going to give you very similar print quality, I would assume, and has some benefits like someone you can call for support and support that you can get.
Hmm.
No offense, Discord support, but there's a difference when there's a vendor standing behind the product that you can call for it.
Yeah.
And even if there's that support, right, the knowledge that you don't have to build the thing in the first place removes so many ways to get it wrong. And so, when I started with this stuff, it was Christmas Day 2012. And the day after December 26th, I know because I got a phone shortly before then, and my Google Photos history just happened to start around the same time. So you can see this very quick progression of, crappy plywood parts, a crappy print with 0.4 millimeter layers.
Yeah.
And then within a month, you can see me printing the parts to replace that one. I got into Delta printers, which
Oh, okay.
are super simple. And I mean, I had a great experience with them. Some people, especially in the 2010s, had challenges around calibration, but I loved my Costles, even when they were designed completely wrong. Like there was an early version of a Costal that used fishing line and spools. It wasn't fishing line, it was kite line, Spectra line. But
Mhm.
Spectra has this challenge where if it's tensioned, just like plastic under tension, it will creep. And so imagine a printer where instead of, GT2 belts where you can go back after a year and it'll probably print the same. All of your motion axes had a different tension. You have to retension them. And not just that, but the number of steps per millimeter had changed. So your
Yeah.
parts are a different size. So there's some, it was early days. And so people were
Yeah.
learning how to do things like that, how to do deployable probes. The first probe was like a little Allen wrench that would deploy with a string and a spring. And now we have a lot more choices that are reliable. But in the early days, right, you could barely buy a kit and the kits were no good. And then once the kits started to get good, you thought, oh wow, the world's so much easier, right? I have instructions, I have a kit that I can buy. And now we're in a world where you don't need any of those things. You can just open the box and you can print. So the question for us is why should I bother with a kit? And so in advance of this Meet the Makers, I feel like this is the question we should be asking ourselves. And so I gave it a little bit of thought. And I think it comes down to three P's. And I think this will be a little more memorable for people. And the first P is people. So you get access to a community that otherwise doesn't need to exist, right? So when you open the box and you click a button and you get a thing, you have no reason to interact with the world. Now you can show them what you've built and then you can interact in that way and you can learn about all the stuff on the side like design and that can be a community you can interact with. But when the printer is part of the project and part of the prints, there's a community of people and those people tend to be a little more dedicated. They tend to be pretty broad in terms of their skills to be able to take on things like that. And those tend to be on average people you're going to learn a lot more from than those who just want a printer and just want to get the prints. And both sides are fine, right? I would much rather have a world where more people, kids can grow up knowing that they can press a button and they can get an object without having to become experts in the same way that, I can print 2D pages and I can put up a flyer and I don't have to think, how do you build a 2D printer, right? It's a good thing that anyone with any software can print a sign. And I think it's the same way with 3D printers. And so that first reason is it's the people. You get access to the community and you have a reason to interact with them. And the more you engage in that, the more mods you deploy, the more you just measure the thing you've got and learn from that. The more math, the more physics, the more electronics, the more mechanics, the more software, the more firmware, the more hardware you're going to learn. A second thing is the market doesn't necessarily favor some things that may make sense for a lot of people, but not for a company. And I think MadMax is a great example of that, right? So this is something you can add to your existing printer for $100. But if you're a vendor, maybe it doesn't make quite as much sense to you because you want to sell a printer.
Yeah.
And so anytime the market maybe favors modifications or a modification can deliver something better, right? And if you're space constrained like me, I'd much rather have a mod that makes my printer better than have to shell out all the money and all the space for a new printer. And I think the other one is performance. And I alluded to some of the reasons, with stuff like the Monolith Zero gantry here and how crazy fast it can print by kind of doing this first principles approach. But I think that's where we see the highest performance these days. And there's almost like a subculture of high performance printing that I've only started to jump into in the last year. But the last few years for me was always, how do I add capabilities? How do I add automatic bed leveling? How do I add panels that I can pop on and off in seconds rather than minutes or tens of minutes? That was ZeroPanels. Or how do I have a probe so I don't have to do the work of manual alignment? I have never in my life done one of those little vernier calibration prints where, you get lines that align like that, but you have to print every time you make a change. And that just to me felt like work. But, 50 hours to develop a probe felt like less work for some reason than that. And, a year later it gets released. So the performance side, I think we're seeing a level that goes beyond what's commercially available. And it kind of brings to mind the hot rod world.
Oh, totally.
Right? Ford's not going to sell you, unless you pay a lot of money and get something like a Mustang GTD or a Ford GT or like some really fast car with a warranty. The things that are going to be accessible to most people, those aren't so accessible price-wise to a lot of people. But, a hot rod where you mod the engine a bit, you get a bit of extra speed or performance at the track. There are vendors that can help you with that, even if the producers of the cars aren't making that an item that you can get at the dealership. Yeah. And I think for people who want the most out of their printers, want the most out of that, want to learn more, then DIY has a place. It will always have a place, and it's just more fun.
Yeah. No, I think that's really well said. And there's a couple things that I was thinking as you were mentioning those that, a lot of the printers that we're talking about that are the cool new printers, the Core 1 L looks fantastic. If I needed another single color printer, it looks like it would be fantastic. Like that, I would be super happy with what I got. Like it's got everything I would want at this point in time. But some of the things that they mentioned that, are things that actually look like they come from mods, like bed fans and stuff to, circulate heat in the chamber and heat up the chamber faster. Like those are things that, I believe were made popular from a mod in the community that these companies have picked up. Same with the motion system for the bamboo and all of these other things that now are like really commonplace are also getting their birth from these people in the DIY space, which isn't a reason to get into DIY, but it's a reason to support DIY for sure. Yeah, and the other thing of being able to, we've got an old V2.1 that if we wanted to, we wouldn't have to get a whole new printer. A lot of it is compatible. We could upgrade to a 2.4 if we wanted to. We could put MadMax, or we could do toolchanger on it. Like we can still upgrade it or update it from what we already have. So there's almost like if you have that, desire to reduce the waste, have to throw away a printer to get something new. I'm thinking that Elegoo Centauri, which we're about to carry, is a fantastic little printer if you want a cheap printer that prints reasonably well. But for multi-material, now they've just said, oh, now you have to get a Centauri 2. You're not going to be able to just do it on the Centauri. So it's this whole thing of like having to throw away to get a new printer that, at least rubs me somewhat the wrong way.
Yeah, I'd say if the things you buy are open source, are documented, then they can never go out of support. And if you can be the support, then the thing you have will never be obsolete.
Yeah.
And I think that has value to a lot of people who don't just, abhor waste, but want to have something that they look at in a way that they don't look at their toaster, right? I don't look at a toaster as a source of pride and joy.
Yeah.
But when I
Oh,
look at some
for
of the
sure.
printers I've built, I'm like, yeah, I mean, I put some of my blood, sweat, and tears, and sometimes literal blood, literal sweat. And I feel like that's it's a good outcome, but it's also that process of getting there that I have advanced my skills,
Yeah.
right? And so there are projects I was able to take on that would never have been possible had I started down the path of just buying a commercial printer.
Yeah. Well, I mean, there are, and I mean, unfortunately, on that side too, you mentioned that sometimes things aren't going to come out because it just doesn't make commercial sense. That is also the case on even just getting, you have a printer from 5 years ago that something happened to it. I don't know. I said my first printer was a XYZ Da Vinci. If I still had that printer, it printed fine. I mean, I guess I could have kept it if I liked painter's tape. But like if something happened to that, I couldn't go back to that company and get that piece anymore. And it's not something that's off the shelf that I could find a replacement for. Like I would be either going and trying to redesign from you know, from nothing to retrofit and spend hundreds of hours probably, design and testing to get something to replace this thing, or I'd be throwing it away. Which the stuff that you're designing, the stuff I think most of the DIY, at least in the Voron community, especially, I mean, those are all things that you can go on DigiKey or you can go on Amazon or AliExpress or whatever, and there's not much risk that that part is no longer going to be available because, XYZ finished, they ran out of their parts and they're like, well, we're probably only going to sell 10 more of these, but we need to make 100. We're just not going to do it, you know.
Yeah,
That
this
kind
is something I didn't appreciate until I got a little more of an inside view to the Voron design team. And if you're just buying a kit, it doesn't really matter how sourceable things are, you just buy the kit. But to source them so that lots of people can make kits and you don't even need to have a kit, but you can still get started, it takes time. It's work. And so parts that are sourceable now and probably will be in the future, it's a really nice element of a lot of these kits that you can buy as well as the printer designs behind them. I mean, when I made my first Voron, it was a V0 back early 2021 to 2020-ish, right around COVID time. I rejoined the community like a lot of people did. There weren't any kits available. There weren't any frame kits even. So I had to cut the extrusions and I took some parts from an old Castle and I chopped them down on a chop saw, and no, they weren't exactly perfect, but they were good enough to get me to the next step.
Yeah, it's I mean it's a community that I really enjoy. And the people like you, I mean, there are hundreds of people in the community of thousands, but hundreds of people that are active contributors in some way. Um, it's amazing. Um, Another question. There have been a lot of changes. I would say this year so far has been the year of tool changers. Um, Multi-filament, multi-material. It seems like both commercial and in the DIY space, whether it's box turtle, stealth changer, MadMax. I mean, it's just the index. I mean, the new whatever Bamboo's going to call their thing, and whatever Prusa's going to call the Bondtech thing that they're doing. Like it's the year of that. Um, what are I guess, the new printer tech things that you've seen or you're seeing being discussed that excite you the most?
Yeah, so I mentioned one of those. I think field oriented control is one of those because with the addition of an encoder to a motor, you now have a way to get better prints to improve reliability of the printing process, and also just the technology behind it is really interesting. And the knowledge you could take an existing stepper and get more performance at lower power consumption out of it is just amazing, right? When you can take existing stuff and deploy smart electronics and chips, honestly, they're doing a lot of the hardest part of the work. So that's certainly something that I found really exciting lately. I would say Index is another one. So this is Bondtech's design, not yet released, so we don't know exactly what the specifics will be for price and capabilities. But the knowledge that you can have an inductive hot end, right? Wrap a coil around a metal piece, and then kind of like an induction stovetop, run current through there, and over air transfer that energy over to something that heats up is really, really interesting and kind of unexpected. And it means that on a tool changer, you can have each of the heads be effectively static, and the only wire is actually the Bowden tube, which allows it to scale for a lower price. I think two heads does most of the work. It covers pretty much all of the use cases. In fact, I'd also say if you have two heads and then you combine it with filament changers, this is part of the year of multi-filament that we're seeing. This just explosion of ideas and accessibility there. I think the two heads plus an automatic filament changer covers all of the use cases. You can do supports with multiple colors at a much lower price, and honestly, I think with to some degree, a better experience overall.
Yeah.
But something like Index, once it exists, is going to have a lot of those benefits as well. It's going to be a proprietary product, so it may not give you the speed you want. It may not fit your printer. It may not be the other attributes you want. So, grain of salt until it exists in a form that people can buy. But from a technology and a technology architecture standpoint, that's been, I think, one of the very interesting things. And the third, I'd say it's a broad technology, but it's cheap SLM changes the game. Because if you can design it, you can ship it off, and then you get this cool thing for $15 or $20 or whatever it is. I mean, all the stuff on the Monolith Zero is showing, I think, is less than $100 in SLM, and that's crazy cheap for something that's going to be rigid, that's going to handle whatever temperature you throw at it, and that you didn't have to put any of your time into making. You just had to send your design, and then it comes back in the mail. So I think as people learn to design for metal SLM, interestingly, it has a lot of the same challenges that you have with plastic, where if you do really long legs, like your octopus, the legs are going to curl up. So it has a lot of the same, if one layer is hotter than the layer above it, then there's a force that gets generated and you want to get curling, right? The reason for curling is differential temperatures. So you have to be aware of those things too, and you don't want, giant areas. You probably want to minimize the material usage, so you probably want to have holes to drain it, kind of like with other methods like stereolithography, where you got a vat of resin and you're heating it with a laser or some other light source to cause it to cure. So the method all has its little quirks, and I don't personally feel like I'm particularly good with them. I've mostly sent designs that Cloak Dwayne has made and for the Monolith Zero, and they've come back and they've occasionally had some lifting, but we're learning how to avoid that. And one of the interesting things about the closed until you're a member on the Monolith Discord program that got maybe 10, 15 tool heads built is that you could see the variation in the parts. Some people had a little bit of curl, others had none. And it's just like with a printer where each one's going to be slightly different, but you can often fix some of those issues with design or with working it in post. So yeah, metal SLM, field-oriented control, and just this whole tool changer, automatic filament changer space is just really interesting.
Yeah. Oh, that's cool. Yeah, I mean, I think those are all exciting things. Have you, I guess, well, I'll go to something else. One of the questions that we have up here is just asking sort of there's two questions I want to ask. First is, what's the craziest printer you've ever built? Or tried to build, I guess. You could say I failed, but...
I mean, a tool changer V0 with no positive lock is pretty crazy, but I'm not going to give that as an answer because it's too easy. In terms of printers that I've built, so there are a few people who've designed and built more printers than me, and you may know some of them. I think Joseph Prusa is probably one of them. I think Max Solin of Voron Design is probably one of them, and the whole Voron team around that he created. Mm-hmm. And then Brooke Drum from PrinterBot designed quite a few things. My first printer was a PrinterBot Junior. But there's one person who, to me, is more interesting than all of those by far. Nicholas Seward may not be a well-known name. This is a math teacher from Arkansas who has has shared a lot of designs to YouTube. And these tend to be designs that a math teacher would create in a good way, to where there isn't any firmware off the shelf that does exactly what you think. So regular printers, right, they're Cartesian. They move in X, Y, and Z. And even if it's a core X, Y, it's a linear combination of two things. So from a control perspective, it's relatively simple that the commands to the stepper are some linear equation. They're not too bad. Deltas are a little more interesting, where you have 3 towers, and then a linear delta is what we normally see, where you have balls with rods, and then you couple in the center a bunch of those kind of parallelogram linkages, but they're on balls on each end, so they can kind of rotate in space. So if you have 3 pairs of those, then the effector with a little hot end pointing down, it moves in a way that's always pointing down. But you can imagine printers that thing on the end swings, right? It doesn't always point down. Or you can imagine different connections of axes. Imagine if all of the axes on all of the motion axes were in the same direction. So there's a printer called Monorail that he did like that. Or what if you didn't even have rails for all of your axes? You just had wheels, and so the printer could just kind of wheel itself along the ground, building increasingly larger prints. Or what if it kind of looked like SCARA, which is a SCARA, look that up. That's where you have angular joints that connect to each other, kind of like robot arms. Well, what if you did a printer with that? So I'd highly encourage, if people want to go down an amazing rat hole, grab some popcorn and look at Nicholas Seward's SEWARD YouTube, as well as his GitHub called Concept Forge, has something like 10 plus completely crazy printers with names like Sextuperon and Monorail and Wally and Simpson. And the most interesting one I ever did is a Gus Simpson. So it's a delta printer. So it's based around a triangle and it's rotationally symmetric. But instead of a linear delta where you have these 3 vertical rods and then, you know, all the parallelograms that connect in the center, pretty familiar to some people, this one is a grounded delta. So imagine just a triangle plate. And then out of that plate on the 3 corners, you have a rod, or you have an arm, and that arm connects like this. And then in the very top, you connect those 3 arms with an effector that has a bunch of bearings. And imagine if each of those arms on the side can rotate. So it kind of looks like this as it moves around. It has shoulders that rotate, and the effector has a whole bunch of coaxial bearings. So each one connects at a slightly different level. They all connect. And so it looks like a spider on top, a 3-legged spider printing your part, where the center points kind of down. It's called Gus Simpson, and that was the most interesting printer I ever made. It uses what's called proportional gear drive linear joints, where you have a motor with a spool that kind of moves them like this, and it's actually gears that you print. And it has a few interesting properties. One of them is a Gus Simpson can print the parts for a larger Gus Simpson. So imagine you're on Mars and you want to build a bigger printer and a bigger printer, and you want to start with what's in your spacecraft, and then you want to print the house. So it has this property where you can print the parts for a larger Gus Simpson. On a Gus Simpson, it can get larger and larger, which is a pretty out there thing to even consider. It also has very few non-printed parts. Almost the whole thing is printed. It's just some bearings and it's a plate and the electronics. So from again, you're trying to print on the moon or Mars, it has a lot of beneficial properties. Another thing is my particular red Gus Simpson, it did 2 prints. It did a little box, but I wasn't calibrated, so it ended up being a slinky, a box-shaped slinky. And then it printed, once I fixed that, a little squirrel, which was the mascot for the printer. And then it melted in the trunk of a car in 2014. I live in California, and I didn't think it would get that hot. And I was wrong, and I underestimated PLA's ability to get soft in a car.
Oh, yeah.
And not all of it melted. I mean, it didn't literally melt into a puddle, but creep is accelerated by higher temperatures for materials. And so if you have PLA under a load, it's going to deform. And so some of the parts ended up looking, you know, kind of funny. They kind of twisted and got deformed. They went a little bit limp on the arms there. And Mr. Tallman of Tallman 3D felt bad. And this is back when, Google circles were a thing, their social network experiment.
Yeah. Mm-hmm.
And Mr. Tallman saw my post of a melted printer and then sent me a box with the latest filaments, all these different nylons. And this was before PETG was the common thing. It was called T-glass, their version. And so I got some cool new filaments, and I have not to this day printed its replacement, but it's the printer I would make again if I were retired. I just think it's too cool. And too few people know about the Gus Simpson, and you should look it up. There are videos on YouTube, GUS Simpson. There are also variants that Nicholas Seward did, like Lisa Simpson, that are, again, interesting ways to use lead screws and bearings and get motion that are a rat hole you will not regret diving into.
Oh, that's awesome. Yeah, I'm looking at it right now. In fact, he's got a link, it looks like, to some videos and all of that. Oh, that's cool.
Can you repeat the name of the channel? There were some people asking.
Yeah,
Yeah, Nick.
I'll put the link. I should be able to share the channel. Here. Yep, here it is. Yeah, it's Nicholas Seward, and here is the link for YouTube. There you go. And
Look at
Augustus Simpson is super cool looking.
Click on the videos link and where you see the grid of videos and just pick something that looks wacky, and you'll see in many cases a video of it moving around in an animation.
Yeah, there's the RepRap monorail looks really cool. It looks like I mean, it looks like they kind of share similar sort of overall design elements, but this one looks like it actually slides on like a linear rail. There's the Hexascardiff, I guess, that is also really nuts to look at. Wow.
They're all nuts. Sextuperon, Hexcardiff, Monorail, RepRap Simpson, Lisa Simpson, all those.
That's
And a
cool.
lot of them, the files are actually available on a GitHub called Concept Forge. And all these are like 8 to 10 years old at least. This stuff's been out there. Like, this is part of why I got into the hobby, just seeing those
Yeah.
crazy kinematics. And then if you've got just enough of the full stack of skills where you could deploy firmware that someone else had written, and you could build the mechanics, and then you could configure them just a little bit, you could make a crazy printer, and you still can to this day. It's just much easier with things like Clipper, where you don't have to modify embedded firmware to be able to create new kinematics.
That's amazing. Sort of to follow up on that, let's talk about like the origin story. So you said that it was sort of part of your, part of the reasons of getting into the hobby. What really got you into 3D printing? You said 2012, so you were an early adopter. What, how did it sort of catch your eye, and why did you decide to pursue it?
Yeah. So in my high school, we had a little CNC machine, a little mill, and I always thought that was really cool. In fact, I had milled the parts to make a quadruped robot way back when, around the turn of the millennia, I guess I get to say. And that was a really fun project. It was, again, the full stack of stuff. First robots and related projects was always like the mechatronic side being exciting to me. That kind of planted the seed. And then much later in life, I had an opportunity to start getting back to some hobbies because my academic side calmed down a little bit around 2012, 2013. And I was like, you know what? These printers are cheap. The cheapest printer I could get was a $400 Printerbot Junior kit. I bet I can make this thing work, and then I can print stuff. And I knew a bit of CAD from before, and I loved it. I dove right into it because within a day I had a printer that was running. Within a day after that, I printed the parts to fix the problems of the printer kit that I had bought, right? It was 89 degrees, but you really want 90 degrees. You can't print your delta corners if they're all twisted. So I had to design and then print the parts to do belt tensioning. That didn't even come out of the box. So another example is it didn't have a printed heated bed. Didn't have a part cooling fan. All these things we take for granted,
Yeah.
we're not there in 2012, but they didn't deter me. And I love that when I was trying to build my dream printer, right, the Ferrari that you build from the regular car parts, a Cossel represented that, because you can imagine it going a lot faster if it doesn't have this big heavy extruder that's moving around and all those motion components. So in the process of getting that to work, we would often use RC rod ends. And you could buy from vendors the rods for Delta with the rod ends already glued, and they would guarantee that they were all the same length because they would build them using a jig, and it was cheap enough that it's worth having them do that versus
Yeah.
doing your own jig. But I was so frustrated because these things had backlash. I'm like, that's not good. You don't want backlash in your motion. I don't know what effects it's going to have. I'd like to start with the best motion system possible, so I know that my prints are going to be the best they can be, and then I'll do the rest in software and make it better. But I shouldn't have to fix the issues in software. I should start with something solid to eliminate the need for it. And so one of the first parts I did, and this is on Thingiverse, is a little mount to which you'd put one of these RC rod ends, and you could poke it with an Allen wrench, and the other side had a dial test indicator. So basically you push it in and it moves a dial and it tells you how much deviation it's seeing. So you could measure the backlash. And it took me 3 or 4 iterations, but I did them in one night. And I could send to the vendor a file that they could then print, so that instead of going back and forth and being like, this is unacceptable, you're going to have to make another one and send to me because you told me it would have a backlash, but it didn't. Here's a file where you can test it yourself to make sure your parts are good before you do the final steps and send it to me. And I thought, wow, this is a completely different interaction with the vendor. This is more like a collaboration than a purchase. And then a week later, my girlfriend had bought some sky binoculars It's these huge binoculars that you wouldn't necessarily take with you on just any hike because they're too big, but they're really great for seeing what's out in the sky. And I happen to live in an area that's fairly narrow, so where we don't get too much light pollution. And we tried to see the moons of Jupiter, and I thought I could see them, but I wasn't sure. And it was hard to see them because the mount that the binoculars came with, it would kind of do this. It was made of ABS, and
Oh,
ABS
yeah.
is fairly flexible. And what I wanted was something rigid. And so over one night, I did 3 iterations of design till I got it right, or 2, or, it doesn't matter. But the point is you can do it in a night. And I made a rigid equivalent that had a box and then a little bit of infill. And it even had the words look up printed on that as like a little Easter egg. And so I made my little binocular tripod mount. And it was so cool when a month later on Thingiverse, after I had posted it, someone else showed me, like they showed a picture of what they had seen. And the day that we got that thing working, we looked up and I could see the 4 Galilean moons of Jupiter from our porch.
Oh,
And I
wow.
thought, like, what an awesome outcome
Yeah.
that I can't get because even though I had a CNC mill at the time, a 1-bedroom apartment was not the place for that.
Yeah.
But I could fit a printer or a few in a small space and get to that amazing outcome. And not only that, I could share it with the world. And so that kind of was the spark for me. And then kind of went idle for a while. Life gets in the way, especially at a startup. And then 2020, I dove back into it because I had more free time because the activities I'd
Okay.
usually do, I couldn't do.
Yeah.
And we got into printing PPE. And then when I was printing PPE, I wanted better materials for that because I felt almost guilty that I was using PLA and Petchy and these things that maybe aren't as good for working professionals. And I wanted things like ABS. And to do ABS, you really want an enclosure. And I have cats, so I wanted to make sure that it was a good enclosure and a good fast printer. And so now all my printers are cat beds as well. They all have enclosures and they can all do materials like ABS that are a little more durable
Mhm.
than things that will melt in your car or even inside if direct sunlight hits them and it's a hot day. That actually happened. I had parts inside that melted on me because the internal stresses with things like hexagonal infill will trap air pockets, and if you have part of it heated and the other side isn't, then you can actually have your parts deform inside the window.
Yeah.
So just that ability to do more and fix more things around me, like there are parts within view that you can't even see here that are printed because a little bit of design plus pretty much any printer goes a long way. And the light mounts that are holding up my lights right now fit on a V0, little triangles that had the right size hole to match the lights that I purchased. And that notion that you can modify your world around you to solve the problems that you see, and you can do that with multiple iteration cycles in the same day is the reason I still get excited to tell others about it, because there's so many times when you fix a problem and you forget that you fixed a problem, and then your fridge breaks and you're cleaning out the fridge and you're like, oh, I remember when the butter used to fly out and I made this really simple as like a C shape that clipped on and
Yeah.
then the butter didn't fly out. And you're like, oh, because it was white and it matched the fridge. And little stories like that, I think many of us have, especially if there's just a little bit of design skill and
Yeah.
a printer that you trust to print.
Yeah. No, I mean, I know that's been an amazing thing for me, and I've had appliance things break and racks and stuff break, and it's just I'm not a great designer, but like I can still make things, and I can still see every once in a while. Yeah, I mean, I open up a little sliding drawer and I'm like, yeah, that's still working. Like, uh, yeah,
And
it's an awesome feeling.
it's less about the printing for me now. I mean, I don't print much. As weird as that sounds, I very rarely print things. But what I'd like to do more is open source hardware and designs that I share with others and shepherding others to develop their skills, mentor to build new things. And so things like MadMax took a while because there was a lot of design and test more than there was a lot of printing involved.
So what drives you then? Obviously, if you're not necessarily using all of your creations all the time, what drives you?
So I have a bit of an academic and research background, and that kind of love for discovery as a hobby manifests in 3D printing when you're
Mhm.
diving into the next level. So first level is you build a printer, you get it to print something, or you do some other, CNC mechatronics thing like a mill that gets you an outcome. The next level is really understanding how it works and making a change. And lots of people who mod their printer are doing that next level of they found a problem and so they source a solution and then they print the solution. And many times they'll have to make small tweaks to make it fit in their environment. For me, it's kind of like the third step is optimizing with measurement to where you learn a principle that closes the loop to where you can then design something better or even potentially question wisdom. And so a lot of the stuff around gantry design, I'm learning so much from things like Monolith Zero because we have cheap sensors where you can press a button and you can get a result. And if you can do a lot of input shaper measurements where an accelerometer measures the shake, you can learn if structural panels matter. You can learn if the height of a tool head and the offset of its mass relative to where those belts are pushing it along, whether that matters. And so I'll often do the actual experiment where you vary a variable, like build a carriage where you have a weight on a stick. And as you raise that stick, you can see how the input shaper measurements kind of go to crap, because as you would expect, the higher that weight is and the farther it is, the more it doesn't like being shaken and the more it shows that that becomes the dominant frequency. Whereas if you balance it and you have your center of force and your center of mass aligned on your carriage, you can get much, much higher speeds and you can actually get much better performance out of your printer with less ringing. It's the same thing with the gantry itself. So on a V0, the rails are here and then the gantry is up there. They're offset to fit it all in the space. It was a real challenge for the team that built that to fit everything in the space, and respect them for what they did. But that design decision goes against the desire to get the absolute top performance in that same space. So for example, what Monolith Zero does differently is, just like the Monolith gantry, those rails are facing inwards. So the belts, one is above and one is below the inward facing Y rails. And so that means all of the forces are balanced. The gantry forces are balanced. The tool head is perfectly balanced. The tool head is rigid. Everything is double supported. It's kind of like designed from first principles, and kind of finding your way back into those and quantifying the effects can be really, really fun. Another example with nudge, there was a lot of measurement for it. Another thing is with MadMax, with that coupling, it takes time to get that right. And I learned that the materials would matter. And so I built a material tester. I took a Raspberry Pi and a load cell that I bought for $10 off Amazon, with a little board included too. You actually get two of each for $10. It's crazy. Little HX 711. And you can download a library for Raspberry Pi and just connect it up, and then it'll measure almost like, a scale, kitchen scale. It'll just measure the force. So if you put that on a single axis that you drive with something like Clipper, then you can write, in my case, it was like 50 to 100 lines of Python, to where you move it to a position and then you have it pull while recording. So you just send it a command, G0, move 10 millimeters at a certain speed, and then just log out all of those values from the load cell, save them, and then find the peak. And what that allowed me to do was measure my magnets, because I learned very quickly that magnets that say they're N52 on Amazon are not going to be real. So you have to test these things. And so if you have a little sled that pulls and measures and it kind of breaks loose at one point, you see a peak where you have the highest magnet force, and then it drops down. And so that shape is really simple. Just look for the peak. And so that was an example of kind of an experimental device that I made that did not take very long. And it meant that I could do other things with it later that were super valuable for that whole project. Like I could take it and I could put it in an oven. Actually, I put it in the DualingZero. DualingZero was the oven because it gets up to 70C. And so I could see how magnet forces dropped with a temperature. And you can start to see it for your N52s. As the temperature goes up, the force goes down. Another thing is, when we were designing MadMax, those pins that are part of the sliding coupling, you want them to be a low friction material, but what's the best material to use? So, maybe it's almost CNC kitchen-like at this point, but I went to McMaster and I bought one of every 1/8 inch rod that they had in plastic and metal. And I built a little friction sled tester thing. And all it did was it would pull while measuring. And this way you could measure the friction force, and you need some kind of weight pushing down. So I just used a stepper. So it's a stepper pushing a screw into two parallel pins. And as it pulls, it just measures the force with a load cell. And so I could generate a diagram, which is on the MadMax page on that GitHub, showing all the different materials we tried. And the softest one, as you might have guessed, was Teflon, right? We think Teflon is slippery. That's the reason it's in our pens. And it was the slipperiest, but it wasn't the most durable. So after all those kind of magnet cycles of attachment, it would deform visibly. Mm-hmm. So I was like, I don't even need to measure it. I know it's not what I want. So what's a harder material that's still next in line for slippery? And so we tested 10 different materials. Didn't take very long. It was like a few hours max once I built the tester. Just had to repurpose it slightly. And then found that acetyl or Delrin, or I forget the other names it goes by, POM, is really durable and very slippery. Not as much as PTFE/Teflon, but really good. So that's a good choice for a coupling where you want to minimize friction
Mhm.
because you don't want to, push on your bed any more than you need because it can cause set screws to come loose. And so then one other example is, you've got a probe now. Why don't you measure the force of that probe and see how your design changes connect to the force? And so I was very happy when I got to the point where we knew the friction, we knew the magnet forces because they had been measured, and I knew that I could, if I change from a pin material to another, I should measure a force change for probing to minimize that probe force, and I could call my shot in the sense that I could guess the delta in probe force and actually know from all the individually measured, materials like magnets and pins what to expect and where it was within that expected bar. So for me, it's understanding the world
Yeah.
and then having that drive back, like the science then drives the engineering, where you can go, okay, well, here's how we do a better tool changer coupling, or here's how we do a better gantry. And so working with people who have that same, I guess, hunger to understand things at a deeper level and then connect them to engineering is what continues to drive me to, do a lot of these projects in an open way.
That's awesome. And I mean, just the way that you describe it, I mean, it sounds like that is fun for you to do that.
It's not always fun. I think it's an important point. It can be fun. Sometimes it is fun, but like that moment of discovery where you're like, oh, I didn't know that that could exist and now it does. And I figured it out. Like another example is you want to have two materials. The traditional way is you put two nozzles on one head. Lots of printers have done that, but then you get this drool problem. So then the next way is you do IDEX. IDEX doesn't have the drool problem because you can move one nozzle off the print while the other one's doing its thing. Or you can use a tool changer, which solves the same problem, but then you have to design this tool changer coupling. And for years I was scared of that. So I thought, well, what if, but then the problem with each of these is that either you have a complex coupling that you have to design that I was scared of for tool changers for many years, or you have an IDEX where you have this lead backpack when you move in Y. You have the second head that's going to slow you down. So I thought, okay, well, what if you just had two gantries? But then the problem is they can smash into each other violently. It can ruin your day and your parts and your printer and your print. So how do you control them in software? What are the cases that you have to handle? Could you even get it to where they both, they operate in the same workspace and one, when it's doing the square, pulls out of the way so the other can go ahead and do its thing? Like, is that even possible? And so that became DualingZero, which to my knowledge was the first open source, downloadable with parts files and firmware dual gantry printer. And there are others that kind of look like that. It's actually kind of similar to if you've been to a shipping yard and you see these gantry cranes that share the same rails. That's an example of a dual gantry system, right? Those can smash into each other if they're not careful, but of course they have safeguards. And so I just reached out to a guy named Turkown on Discord who had done some firmware for Clipper. And this is one of those experiences you only get in the world of open source where I think I reached out on a Friday night and he said, it was his morning. He said, hey, let me take a look. And then he got back to me and said, hey, yeah, this time should work for us to debug because I hadn't built kinematics in Clipper. That was above my skill level for sure. But I could get it like 90% of the way. I just couldn't get it the last 10% where you really had to understand the internals. And so I had that same webcam you just saw pointed down at the printer with someone who lived in France who was remotely debugging and looking at what the web interface showed and telling me what changes to make in the firmware. And within a few hours, we got it working. And then I had the world's first dual gantry printer, which was crazy.
Yeah.
And that moment is really exciting, but that moment requires a lot of work and it's not for everyone because there's a lot of pain before you get through to the pleasure. But when there's a journey of discovery, right, it's worthwhile, even if it's not fun along the whole way. Yeah. So sometimes I'll do the projects that are like Netflix for me, right? I'm just wrenching on a printer, having fun. The merging two printers with MadMax is exactly like that. I don't have to design anything. I tore one printer apart. Now I can apply the parts to another one and just wrench, not be on a screen. But then there are projects where you need to, build or invent new ways of testing to get to the outcome, and then for others to see the benefits. And some days you just want to sit back on the couch, and other days you want to do the run that requires a lot of elevation.
Yeah. Hey, that's a great story. I'm sure it's an amazing experience. I'm thinking that also being in this community, I mean, it's unreal. You couldn't even, I will say, I mean, I had a Prusa, they're fantastic because their support is amazing. You do talk to somebody, it's awesome. But if you were saying, hey, I want to do this brand new thing that no one's ever done before with, with this, your example is with the firmware, but but with this thing, there's really not many places like that. I think that you could have somebody that is part of a major project sit down and take their time to help you because they obviously probably have some sort of interest or passion as well. The
Yeah,
same.
you don't
Same.
need to have the full stack of skills anymore. You just need to have the skills to find people who have the other skills.
Yeah. And
And
they're
if
willing to do it. They're willing to take their time to do it.
so, maybe I can make a call to your viewers. So there's something exactly in this direction, and then maybe we close this thing out, give away some stuff.
Sure. I've got one question that's just about your educational background or academic background, but
Okay.
then yes.
Yeah, let me show the viewers something that there's a good chance they've never seen and they'll be confused
Oh,
by, but
sweet.
interested by.
I already thought
So
the Monolith Zero gantry was
let's do
pretty
this.
dang awesome.
Yeah. So have you seen this?
I saw it. I saw it right before we had this interview.
Well, do you have
Before
any
we could
idea what
talk
it is?
about it.
Right? It looks. What is this? Right? Okay. So we got some axes. Here's another one that does the same thing but looks very different. Looks kind of like almost like a V8 engine, right?
Yeah.
So I went into more detail on this. I did a stream to release MadMax with and invited all the people who had built one as part of the beta program. It's up on YouTube. Just search for MadMax release stream. This was like the one more thing from that. So I've always wanted an automatic filament changer, but a lot of my printers have two heads. You saw the double dragon that
Mhm.
now is a tool changer. Behind me, you saw the DualingZero. So when you have two heads, but you want to have a bunch of filaments and choose from them in software, how do you do that? Well, you can have two separate, you got your MMU here and your MMU there. So two box turtles or two enraged rabbit carrot feeders. But what if you want to have one single bank that you share? Then you have a bunch of benefits. One is you can pick whatever you want to print with without having to do any of the purge things. So you just pick the two colors you want for that print.
Mhm.
But another possibility is if you have two heads and you can route all of your filaments to wherever your inactive head is, then you can move it while the other one goes ahead. And I was watching some of the Meet the Makers beforehand, and when you had Kevin on, one of the questions was the main Clipper developer. It was, what about asynchronous stuff? And the example that came up was, well, what if you could pull one filament while you push the other? And so let's imagine you had that capability. Well, you'd need a way to route from a set of inputs. These are 4 inputs to a left or a right output to each of the two heads that you have.
Mm-hmm.
So this is an N to 2 multiplexer. It takes, and it scales linearly. You have N inputs, and then each of those splits in 2. So this is one direction. This is kind of what it looks like on the inside. So this is a valve for filament. And I looked online. I could not find an example. I mean, you could find valves for gas, like air valves. You can find valves for liquid, but I couldn't find a valve for rigid filament. And so I made one. So it's a little Y shape in here, and the internal geometry of this gray part is such that there are 2 positions, and there's a little magnetic spring here.
That's cool.
Real simple, just 2 parts. And so when this bearing, which is a cam, aligns with the valve, it puts it in one position, and then when it's away, it's in a different position. Almost like a valve on an engine. Real similar, but there's a hole for filament. So this is like a Y shape that, based on the position of the shaft, chooses. So what makes this interesting is, what if you want to have one filament move while the other's going? Well, you can't have your camshaft change the value of one of them. So you want something that goes all the way around. You want to be able to turn it one direction or the other based upon where one of these is. And you want a way to have a left and a right, or a, head 1, head 2 kind of thing. So if you combine a bunch of them in a stack, and you have, very similar to how Prusa does their MMU or the Pico MMU does it, or really any camshaft for anything that does the valves on an engine does.
Kind of thing.
The selector, it looks, it's got a bunch of bumps that are all indexed within there. You can't see it here. Of course, it's a double supported shaft because I do those all the time. But it's really simple, right? It's a motor and a camshaft and then a stack of these little valves. And so what this allows you to do, if there was appropriate software control, which I haven't done, and I'd encourage people to reach out to me if they have a 2-head printer and they want to mess around with this stuff and they've got a bit of clipper skill and desire. So this is a selector. So you could imagine mounting that as a replacement to the plate in a box turtle. And so your filaments would come in, all of your inputs, and then you'd have a 4-into-1 coupler here and a 4-into-1 coupler there, and each one goes to one side and each of those goes to a different head. So I think that's pretty cool, pretty relatively straightforward. This is equally simple, but I think more interesting in how it's mechanically constructed. So the other way you can do it is you can have a whole bunch of inputs. Imagine 4 filament inputs, and each of these is a selector, but it's spring loaded, and it's spring loaded in an interesting way. So let's say I move one of these selectors to an input. And imagine each of these connects to one head. So left
Mhm.
and right are one and two. So I would have filament going through this. But what if I want the other one to pass through it? Well, I mean, one
Oh,
design is I could
cool.
have a chain that goes around, or I could just use these little linear things.
So the little spring is gonna just hop underneath it, basically. Oh, look at that.
And so what that's able to do, like imagine you're moving this, well, the other one passes through. It's like a
Oh, that's
virtual
so
pass-through
cool.
design. And so if nothing's connected, they just move about half the distance. You can see them both moving at the same time there
Yeah.
in the center. But if one of them is locked, the other one has just enough travel to where it moves all the way around. And it's using a flexure, which is anytime you have a single part that deforms, but in a controlled way. But then I've also got a spring to return it to that position. So, it's all plastic, it's real simple parts. So this is a design that would allow you to have a bunch of inputs connected to 2 outputs. But I don't have the full stack of skills or interest for this. So if anyone does, they should reach out because I think that would be a really cool way, especially like take a front plate of a box turtle and then
Yeah.
put this on. And I don't think the software would even be that bad. You might be able to do it with macros, but I know the interaction between a multi-head printer like IDEX, dual gantry, or toolchanger, along with the MMU side, is kind of on the edge of what's possible, and you'd probably
The
have to
hardware is super
fix something.
cool.
But the hardware is relatively straightforward. I just haven't released it yet because there are always a few little things you want to tweak once you've built it. But I mean, this was the first prototype that I built. It came out pretty good. This one had a few iterations, but very quickly got to a place that I think was pretty solid.
That's awesome.
So
That
yeah,
really is cool. Thanks for sharing that.
sure. So I think you said you had one more question, and then we'll
Yeah.
uh, we'll step out,
Cool.
give our
Well, that's
listeners
what I'm
back the
going to
time.
talk about tomorrow when I get to the office because that's awesome. Yeah, so somebody was just asking, I mean, you mentioned sort of how you got into things in high school. I don't know if you really went over sort of what your academic background is. I assume it's related to things that you're doing, but yeah, what is your academic background?
So it's actually computer networking. It's completely
Oh,
unrelated. So for me, the physical side is you get bits and you get atoms, and that can be really fun, frustrating too, but really fun. Whereas work for me is mostly the bits. So I think like a lot of software developers, which you can let me into, printing and mechatronics in general it's like a more physical connection to the things that we know that we can apply our skills to, but we can also
mhm.
get an output from that isn't pixels on a screen or a script that works.
Do you have I guess do you have a sort of a day job in the industry then? Is that what you do, like computer related stuff?
Yeah, it's related to computers and security.
Okay, very cool. Cool. Yeah, no, that's it. We have the trivia questions. Is there anything else that you guys want to touch? Alan, do you have any other questions that sort of have come up that you want to ask?
Um, I can talk to Zruncho later because we're coming up on 2 hours here. So
Okay. One thing we do ask, there will be people that see this afterwards, that will end up having questions. I assume it's cool that either Alan or myself reach out to you and ask any sort of follow-up questions just through Discord or whatever.
Yeah, that's great. So you can reach out to me via Discord, but I would much prefer that on the DoomCube Discord. A lot of the projects I've mentioned, and a lot of the ones that are on that
Um,
3dprintersfrance.com have their own channels. MadMax has a channel, F-Zero, Try-Zero. These things all have channels. And the best way to get support is not to message the creator who's going to say, just go to
yeah,
the channel he told you
like
to go
go to the
to, like
channel
I'm doing
about the
right now.
project.
And don't at mention me there, but ask the community there, see what they
Yeah,
can do. And others are going to be more likely to be around when you ask the question. And they're often going to give you a better answer because they have a broader set of experiences.
very cool. Perfect. Yeah, so let's do the trivia questions. We have, let's see, we have two trivia questions. We tend to do giveaways for the trivia. We just launched, I think we have 28 new filament SKUs, so we'll do something filament related that just launched, including we now have a glow in the dark ASA. We did a couple other yeah, really cool ASAs. I'm spacing here, and a couple new things for us that we haven't done before in PLA, which are sort of our two most popular materials. So why don't we do the first one, which will be for two spools of a filament, any kind of ambrosia, or we could do like a $30 gift card, sort of whatever you prefer. And you can just, if you win, you reach out to info@west3d and we will get you all taken care of. So let's see. The very first trivia question it looks like we had for you, or you had, um, what is the source of your Discord handle? How'd you come? Uh, someone's gonna have to, it's a trivia question. So someone's gonna have to say something and hopefully it's close. And then it sounds like you need to explain after. Is that right?
So how does the trivia work? People submit their questions
People
to
submit their responses.
info@west3d.
They're going to
No.
submit their responses live here. So
Oh, so they submit them live. Okay.
you'll see. If you're not on the YouTube, are you on YouTube?
I'm looking at the YouTube now. Yeah, I
Okay.
don't see any answers yet,
So go
but
on the
very few
live.
people will
Yeah.
know this one.
Stay in the live, and then basically, yeah. If anybody's like us really close, if it's something really challenging, you can say, "Hey, stop! Somebody got really close," and that's how we'll go. Since I'm guessing there may not be like a definitive answer. Is that right?
Oh, there's a definitive answer
Okay.
for what the name means,
Okay.
but
All right.
I don't think it's Googleable.
Okay. So let's go ahead and do that. So again, the question, and there is a slight delay, so it'll take a little bit. But the question is basically just how'd you come up with the name Zruncho or Zruncho 3D?
Okay, so I should answer it now.
No, we're gonna see here. So
We're
someone
gonna see.
said
So I'll give people a
lunch.
hint, which is it is not uh, based on a natively English word or the usual, alphabet for English words.
Hmm. See, I try to guess in my head while we're waiting here.
No, it predates ChatGPT. That is not the answer.
So the hint is that it doesn't use sort of the Latin alphabet. Let's ask AI. Do it. I'm curious.
Okay, you want the answer?
Let's go ahead. Corn stick. No clue. Snacks.
What kind of
Japanese.
snacks? No, not Japanese. What kind of
Okay, but
snacks?
hey, snacks
We're
with
getting there.
snacks like on the right, on the
It's
right.
getting warm. It's getting
It's
warm.
getting warmer. Is it is it not using the alphabet or is it just a different language?
So if the original word is in Cyrillic,
Okay. Favorite international food, it's some anime. Uh
not Japanese.
I'm gonna let like one or two more people put something through and we can move to the next question. I'll let you answer it. And then I will come up with some other trivia that we can use. Um, okay, go ahead. I'm curious now. I'm really curious.
Okay, yeah. So the answer to where the Discord handle comes from, Zruncho, is that in Bulgaria there's a cheese puff snack called Zruncho.
Oh, well, so Mashinza actually answered that before you said that. So is that right? It's a corn snack popular in Bulgaria?
Yeah, that's it.
Hey,
Yeah, they got it.
okay. Look at that. That's awesome. Now, Mashinza, was that something that that you had AI tell you? Did you Google what is rancho? And tacos, I guess I'm trying to see here. Did tacos say corn-based snack? Corn sticks was more in Jonas chat. Are they sticks?
No, they're the kind that look like packing peanuts, but taste marginally better.
Okay. Well, that was close. I'm gonna go with Mashinza there on my live chat. That's what I got. And Morton can win. He wins a lot, but we still we'll let him win.
Yeah, Eastern European snacks. I think that hint was enough probably for ChatGPT to
Oh,
figure out the
yep.
rest.
It looks like what he did.
So someone
Uh,
addressed a package to me once that said Zruncho the Magnificent. I thought, do they have any idea they're saying Cheese Puff the Magnificent? And they probably did not, which was ridiculous.
well, Mashinza, you can get either some filament or yeah, we'll send you a gift card. He used to work with us. I'm sure can use it. So very cool. Let's see the second one here. Which YouTuber created a video which made the double dragon possible?
I think people are likely to get that one. And if they're Googling, it's going to be pretty quick.
The question again, and again, we have a delay, so if you've said it, I apologize. I'm gonna say it again. But the question again, which YouTuber created a video which made the double dragon possible? It's not Lost in Tech.
Well, I'll give a hint. They've designed and released printers.
It's not Nathan Builds Robots. It's not Canuck, the creator. Let's see. Daniel San, no possible.
We'll drop another hint in 15 seconds if people don't get it yet.
Not Rolohan.
No, it predates Roll-On. Well, then this may end up being an ad for a channel that has some really great content. There we go. Eddie the Engineer. Correct. Yep. So Eddie the Engineer did has a Frankenvoron repo that had like an IDEX Trident, and that got refined into the Tridex design. That got, I guess, open sourced as that. So yeah, Eddie the Engineer's got some great deep dives into how steppers work, and I'd recommend a lot of that content. I really wish they were doing more, but I know life gets in the way.
That it does. Speaking of, I did say we're going to keep this under 2 hours, and we've got 1 minute. If there's any dying questions, throw them in chat. I'm going to start a little sign out, and if I see a type of question, I'll just blurt it out before we shut everything off. But Zruncho, thank you so much. It's awesome. Again, some of the projects you work on or work with, we've used. Now I really want to use or really want to build. It's amazing to be able to talk to you. You seem like a really bright guy, really love what you do. And I really like hearing about sort of the approach that you take and some of the things that you've done. So thank you so much for taking the time. It's 2 hours out of your weekend. You know, we all I know you said you have another job. I mean, that is time out of your free time. I really appreciate it. And I'm hoping the people that were watching and that watch in the future enjoyed it as well.
Yeah, I mean, I hope if people got one thing out of this, it's a little bit of motivation, a little bit of inspiration, that even when it's, a little hard, it's worth it to get to the end of where you can share things with people, because the best feeling in the world is waking up in the morning and someone built your printer, or they built your mod, or they just, they shared a picture that they took with a telescope adapter or some little thing like that someone else found valuable. So had a great time. Thanks for inviting me, and let's stay in touch.
Yeah. Thank you. Take care.
There is one last thing.
Oh yes.
So who would you like to see do this live stream?
I didn't think of that in advance.
It's not an advanced thing.
Is there if you were to watch something and just want to have hear a conversation like this from somebody that, that you admire or you think would be cool, is there anybody that comes to mind?
Yeah, I think if the scope is people who make things that are relevant to open source 3D printing, I think Chirpy would come to mind as someone who's designed a lot of the tool heads that we use, and I'm sure their insights would be pretty interesting. Mm-hmm. I also mentioned Andrew. He's based in Australia. He did the Clipper firmware for field-oriented control, and that could be a pretty interesting technical deep dive. Of course, there are a lot of people on the Voron design team that I think have insights to share. People like Steve Builds. I don't know if you've had him on.
Mhm.
Awesome.
Those would be a few names you could seek out and see if they're interested.
Yeah, I mean, basically we take this and we make a list, and it's either when opportunity strikes. So, we see someone at Vice and we're like, hey, people have asked to have you on. Or, we just come across people. It's like, hey, it would be amazing. And we get the list from people like you. So I appreciate it. I know Chirpy's come up a couple times.
Yeah,
Great.
we spoke in the past. Maybe we can talk about it again.
Yeah. Awesome. Cool.
Cool. Well, thank you.
Zruncho, again, thank you so much. If anything comes up, I'll direct people either to the DoomCube Discord or we'll reach out to you to ask any follow-ups.
Sounds good. Cheers.
Sweet. All right. Take care.